Welcome back. In the previous episode, we discussed how to enqueue and dequeue sounds in a particular order, giving a little bit of a gap between those. So if you haven't watched that, I suggest you check that out as it has important code that will help inform you during this episode. But if you're ready, let's continue. So in this episode, we're going to expand on our queue in order to allow for priorities and for our sounds to expire from the queue whenever they last way too long in that queue. The reason why this is important is because sometimes some sounds just need to be played sooner. And sometimes when your sounds are in the queue for way too long, they're no longer relevant to the current situation. For example, when you're playing multiplayer in Halo, the announcer tends to veer towards two different things: the objectives within that multiplayer match and things like medals that are telling you about your personal experience. So let's say you are playing a game of Assault and you get 5 kills in a row, and then immediately after you plant the bomb in your opponent's base. So there's a lot of announcements that come with that. You're going to get the double kill, the triple kill, you're going to get kill frenzy, and then you're also going to get bomb planted. So in this order, we should expect double kill, triple kill, kill frenzy, and then the bomb planted. But since these all take a good amount of time to accomplish, getting each of those announcements in order, that bomb planted could be several seconds now behind than when you actually did the objective. So you need to make a decision on whether or not what's more important. Do I want to hear every single announcement for all of these different medals, or do I want to know that the bomb was planted? That's what's going to be very useful for our priority system. And then also, let's say you did put bomb planted on a lower priority. Do we still want to play that announcement way down the line when it is no longer relevant? The bomb might not even be planted at that point. So we want that to expire after, say, 5 seconds, because then the information no longer is useful. So let's give that a go and see how it works. So what we built last time was a queue of audio events, but now we need a little bit more information. Right now we need the priority that we're going to set for this event, and we're also going to tell the queue how long we actually want this sound to remain in the queue. That's too much information to really store in a map, so what we're going to make is a struct to put into this queue instead. So we're going to make a new use struct. And since we want this to work in blueprints, we do need to make this a blueprint type in order to fill out the information. It's going to be a struct with our API. And we're just going to call this WHQ audio. So what do we need in here? First off, we need to make sure that we have our generated body. And then obviously we will want to have our event itself, which we're going to want to be able to edit on certain objects, but we also want to be able to see it in Blueprint and write to it in Blueprint. So we're just going to have our TObject pointer, UAI audio event, and this is going to be our audio event, just like before. So now let's work on our priority. So same deal. We want it to be editable and also read-write from Blueprint. But we're going to add a couple more things just to make sure that we don't falter with our priority. Priorities should never be negative, for one, and priorities should probably be clamped to a reasonable amount. So we're going to use the clamp mid, UI min, and then clamp max, UI max in order to make sure that our users are using this correctly. So you do that with meta, and starting with clamp min, which we're going to give a value of 1, and then UI min, which we're also going to give a value of 1. And then we're going to do the exact same thing with our maximums, which we're just going to clamp to like 10. You could make an argument for anything larger than that, but for now, we're going to keep it to a simple 1 to 10 priority system. All right, that's good. So we're going to make int32 priority, and we're going to set it to something in the middle. That way, by default, you have something that can go up or down. If you either set it to the minimum of 1 or the maximum of 10, you could easily get yourself stuck to where you have a lot of items that are the exact same priority, and then suddenly you can't go above or below that. So we're just going to set it to 5. And then we need to know how long we're allowing to have this sound in the queue. So same deal. And then we're also going to clamp this. Because this can never be negative. And we're going to make this a float. And we're going to set this to something reasonable like 5 seconds. And in order for the max allowed queue time to actually work properly, this struct needs to know when it was queued in order to know when it's going to be dequeued, or rather removed from the queue once it expires. So we're just going to make a separate cached time that we're going to be able to put in when this sound is actually queued. And there we go. So now we just need to replace our queue value. Instead of UAK audio event, we're going to want it to be our WHQ audio struct. And this, of course, means that our onQueue needs to change from the audio event to the FWHQ audio struct. You could, if you want, keep the current onQueue function to have this be passed in to a queue audio. So actually, we will keep it that way, and then just make an additional function. And since it is a blueprint event, you do have to have unique event names. So we're just going to call this onQueue struct and onQueue sound, just for now. So the first thing that we're going to do is we're going to actually just fix our onQueue sound function, so that way it utilizes our onQueue struct function. So we didn't actually set a constructor for our WHQ audio struct, which is fine. We're just going to have all of it be defaulted, except we're just going to replace the audio event. And then we're just going to pass that into our onQueue struct. Here's what we're going to do first. I would still like to validate that the audio event within the queue audio is actually valid. Mostly just a safety check, and it really just saves us from a lot of headache later. So now we need to tell this struct when it was queued, And we're going to get that from the world just like we've done before. And in fact, since we've done this before, we're just going to do a little bit of copy pasting. And then we're just going to have our time queued be that current time. Before, we were always putting things at the back of the queue, but we now need to put items into the queue based on their priority. And if their priority is equal, we need to make sure it's at the back of the equal priorities because it's the last thing that was queued. We want to make sure that it was played after all of the things that were placed before it. So we need an insert index to know where in the queue we're actually going to insert this item. And for now, we're going to pretend that we're going to insert the item at the back and then update it later. So now we're going to iterate through all the objects in this queue to see if our current object has a higher or equal priority. So we're going to use a for loop for that. So the first thing that we're going to check is that our current priority is higher than the ith priority in the queue. And if it is, great, we found the position we want to be in, and then we can break from the for loop. If we make it past this point, we now know that we are either equal to or less than the current priority. If our current item has a priority less than the ith element, then we know we can move on. But if we have an item that is equal to the current element, we're going to do something a little bit different. So we're going to apply the same concept when we were greater than the ith element, except now we're going to put it behind the ith element because we want to be after them in the queue because of chronological. And we don't actually want to break here. What we want to do is keep iterating because if we keep running into, and we don't actually want to break here because, and we don't actually want to break here because there could be more elements that have the exact same priority as well. And we want to make sure that we are behind all of them, not just the first thing that happens to have this priority. So we're just going to keep iterating through, and every single time that we equal the priority, then we're going to set it to that I plus 1 just as before. And then after all that is done, then we can insert it afterwards. So before we did an add function with our queue, this time we're going to do an insert function, so that way it doesn't come into the back, but it comes into the insert index that we decide on. And that's all there is to it. Now we need to augment our Dequeue next function in order to take away objects that are no longer valid in the queue, primarily to make sure that we are expiring items. So most of this is going to be the same, but this inner thing where we're playing the audio event is going to change. The way that we're going to look through our items in the queue to find a valid one is by using an iterator on the queue, which is going to start us at the beginning of the queue and then keep going forward until we find one that's valid. So to do that, we're going to do the create iterator function. This for loop is going to allow us to go through each element in order, and we're going to remove the item from the iterator no matter what. And if it is valid, we're just going to play the thing that we just removed. And if it's invalid, then we just do nothing. And it gets removed from the iterator automatically just by this process. So first we're going to grab our element. By doing a pointer to the element within the iterator. Now that we have that, we can remove the item from the queue, which we're going to do that with the iterator's remove current function. Now beware, there is a reason why I made a copy of our queue audio first before I removed it from the iterator, because this item in the iterator is now invalid. We removed it, so we can't use it anymore, but we made a copy of it so we can use that instead. So we need to find a way to know if this item is valid or not. And we're going to make a function called canBeDequeued in order to determine that for us. And we're just going to pass in our struct. So let's make that now. It's going to be a bool, canBeDequeued, and we're going to take our queue audio and it's going to be a const function. So first thing, we're going to check to see if the audio event is valid. I know we're checking that a lot, but making sure that the audio event is valid is going to be very crucial, because if it's not valid, we don't want to play this. We don't want to push it through the process. This should never happen because of how many times we are checking the audio event, but it is a safety measure. You never know. And now we need to check to see if we have expired from the queue, which is going to use the time queued variable that we placed into our struct. So we're going to use a new world function that's going to be time sense. And what are we checking the time against? We're checking against our time queued. And we need to check if this is going to be greater than or equal to our max queue time. If we have exceeded this time, then we know that we have expired. And if we've made it to the end, we know that this indeed can be dequeued. So that is finished, and we already have our if statement ready to go. So we can now be dequeued. So we play the audio. And then we're going to make sure that we break from our for loop so that we don't continue playing multiple pieces of audio. We're having some issue with our play function because it's no longer taking the right thing. We can just do queueAudio.audio event instead. You also can just pass it into the play function. I think this is just a little bit easier though. And that's all there is to it, really. Let's give it a try, let's test it out and see how our struct changes things. So we're going to go back into our level blueprint in order to test our work. And things are going to be quite a bit different. So we're going to remove all of these. And instead of Enqueue, we're now going to Enqueue our struct, which we need to form the struct from right here, which we can do by making a WHQ audio. So what we're going to do is we're going to play these electronic clicks like last time, except we're going to play them in a specific order. So click number 1 is going to remain at 5. And then we're going to mimic this a few times. I'm not going to do anything with the last one. We're going to try something different with that. So for this one, we're going to do a priority of 1, and then a priority of 7. Electronic click 2, electronic click 3. So based on our system, this should go first, this should go next, and this should go last. But what about this last one? Well, what I'm going to do is I'm going to make a delay function, and I'm going to set it to, say, 3 seconds. And then once that's done, we're going to Enqueue this next thing, but I'm going to set this to just 1 second. And in theory, if we set everything correct, this will go first, this will go second, this will go third, and this will have expired from our queue, since it is a priority of 1, and it is definitely waited longer than a second to happen. So let's see if that's what our results are. And we're angry. Oh, that's why I need to make sure that we are targeting our queue system. All right, let's test it out. We did not get the results that I expected. Oh, you guys probably saw this before I did. I made a little goof. We're going to do that because we don't want to toss it if it's actually valid. And we're going to try that again. Oh, I did do some bad logic here. I do actually not need the delay. We're just going to Enqueue this immediately, and we're going to give it a very low priority and have it get kicked out pretty quick. So 0.1 seconds. So now we will have these 3 in order as we did before, but this one should get kicked out and never be heard. There we go. That looks good to me. So that's all we have for this queuing system as of right now. Now we can expand upon this. We can give the ability to open and close the queue so that things can stop being put into the queue, or even freeze the queue so that way things can go into the queue but can't be played from the queue. It also creates a possibility for a conditional system, because while things were valid when we were trying to queue them, we may not want to play them later on down the line. I highly suggest that you all experiment with this kind of stuff. And if you want to take a look at the source code and how I've expanded upon it, there is a link to the GitHub down in the description, and that gives you access to all of my little projects that will hopefully end up on YouTube soon. Thank you.